All right, couple things. One, let me mark James here. One, the first unit was a little rough because it was so long. We were working on it for like 2 months, okay? And typically we would not be on a unit for 2 months, like at the longest, maybe a month, maybe a month and a half. But that's like a big unit, and the last unit was not a big unit. I was very, very, very gracious and lenient with letting you guys turn in work late. That is not typically what I do, but I'm trying to be thoughtful of everyone's situation and the fact that we are all learning online together. Like, I'm adjusting, you're adjusting. However, now that we're used to it, this unit, I'm going to be a little bit less gracious, because at the end of the day, you guys need to know that you are responsible for whatever you're supposed to be doing. So, a couple things I told first block. One, if you know that you know, and this has nothing to do with me, if you know that you did not pay attention to the last unit and you slacked off, what I would probably recommend is you turn on your camera. It's up to you at the end of the day. But if you turn on your camera, you are more likely to hold yourself accountable because you know that I can see you. So you're not going to be on your phone. You're not going to be playing video games. You're not going to be texting, sleeping, not at the computer, right? Because I'm telling you right now, my pet peeve is for people to come to me in December and say, what can I do to pass? I'm going to look at you. I'm going to say, you could have did your work. Okay. So even if, like right now, like Ariane turned his camera, even though I can't see him, he's at least a little bit more accountable because he knows I can see. Yes, I can see. Thank you. He knows that I can partially see him, right? So if that's going to help you, turn on your camera. So yeah, I don't like looking at black boxes, but at the end of the day, like I already passed this class, right? I'm going to do what I can for you guys to help you guys pass. But like how I was taking work 2 weeks ago that we did in August, that is very unusual for me, okay? Because when you go out in the real world, when you say, can I turn this in 3 weeks late? They're gonna look at you like you're crazy, okay? And I do the same thing, but I'm just trying to be understanding, okay? So this next unit hopefully won't take us but maybe a month. And even still, that's a long time, but it's just because I only see you guys twice a week, okay? And not even for a full hour. All right, so this next unit we're gonna start is on matter. And I'm hoping that it is a good and easy unit. There is no math in this unit, so that's a good thing. But there is a lot of concepts you got to understand. We do have some notes. Let me just show you where we are in Schoology for a second. I'm working on putting the notes into a Google form because last period they asked me to put in a Google form. So let me just show you where we are though. All right, we are finally out of the Nature of Science folder. All right, so I'm looking at you guys on this screen. So, all right, so if you scroll down, you can either still use the classroom if you want. You can click today's lesson. So today's lesson and the homework for the next class are going to be the same page. But we're in this matter folder now. So hopefully it takes us just a month. I should just be looking right here. Okay, so I'm going to click the matter folder. All right, so these are kind of the topics we're going to cover. I haven't published a lot of these folders, but stuff that you guys probably know: states of matter, physical and chemical properties, phase changes. We're going to spend a little time on chemical changes, matter concept map. We're going to talk about elements, compounds, and mixtures, and then some more stuff on mixtures. So today we're in this states of matter folder, and we're on this GPB 201 notes. Now, what I'm gonna do is, this is your homework, and we're gonna do part of it in class. So I'm trying to help you out by us watching some of the video in class. Some people are saying they're having a hard time opening these notes, so you can download it if you want to print it. You do need a notebook every day for class, okay? So if you can't see this, what I'm trying to do right now, that's what I'm trying to work on. I'm trying to put these notes in a Google Doc so you can write on top of them. I know a lot of people don't like Google Docs, so you don't have to use it. If you want to just use this, you can just click it. You can hit download file, and it should open up either down there or, let me come back here. If I just click it here, it's still downloading. This is, let's see, should be one you don't have to download. Let's try this one. There we go. You click view on this one, it pops up right here. So this is, so we're gonna do, my goal is for us to get through this first page today. And then for homework by Wednesday, you guys can do the second page. And it's not too bad, okay? All right, so that's what the folder we're gonna be in. That's kind of what we're doing today. I'm gonna show you guys some quick videos on some kind of cool videos. I know they're choppy sometimes, so I apologize, but I mean, if we were all in school, I would probably do these 2 demonstrations in person, but I mean, I could do it here, but there's nobody to volunteer for me because I'm here by myself. So, all right, let me pull up these 2 videos. Anybody heard of, you can do a thumbs up if you have, anybody heard of elephant toothpaste? Oops. Nobody's heard of elephant toothpaste, okay. So we'll do
that really thick stuff, right? I know what you're talking about, I just can't describe it very well.
Yep, you're right. All right, give me a second. Let me see if I can find it here. There's a couple of videos, but let me find a good one. All right, we'll do this one. And I'm gonna start it. Actually, there was one where, we'll just do this one. All right, let me share my screen.
Where we mix the things together and you get this big, huge reaction, and it's probably the most visited little page there on our website.
Really? That one, yeah.
And so a lot of people
You guys
ask what
hear
are
it?
the ingredients, and so our kids here have kind of helped us out. What is the secret ingredient? What is it?
Hydrogen peroxide.
Hydrogen peroxide. That's right. And I showed you a little bit earlier because I have a cut. What happens when you put hydrogen peroxide on your
It
hand?
bubbles.
It bubbles. And those bubbles are made out of, do you remember?
Oxygen.
See, these
Boy,
kids are
oh boy.
good. Oxygen, all right? So look what we did.
Come on.
So we have 4 tests set up, and everything is important that you know that everything's the same. So what do you see here, Sam? You've got how much in each one of them?
This is about 30 milliliters.
Yeah, about 30 in this one, 30 all the way across. And what was the ingredient that you put inside if we could see
We
bubbles?
put in soap.
Yep, a little
liquid
bit of soap. And our catalyst over here called potassium iodide. And it's so important that we use them naked without in some little syringes without the tips. All right, so let's try it there. Sam, you want to try the first one for me? So try the 3%, and this is where hopefully Mark put on your safety glasses.
Oh, yes.
Yes, all right.
Absolutely,
We always
thank you.
practice safe science.
Oh,
All right,
I've
there you
seen this
go.
one before,
This is
Sam,
nice.
just so you know.
See, there's a little bubbling going on there. That's not so bad, is it?
No.
But why don't we try 7%? Because wouldn't 7 be fun? All right, so why don't we try a little
Go
7%?
for it,
Anna's in there. Nice job. Got it. And
Ah,
so that's
a little
pretty good.
busier.
Here, I'm going to
Oh,
help
yeah.
you with this one here. This is a
Yeah.
15% that's over here. Should we do a 30 over here? All right.
Ah,
That's a pretty
yeah.
nice one. We're actually seeing bubbles of oxygen start to come out. This is the bad daddy. This
There it goes.
You gotta love this one here.
We've actually had to run for our lives here at 9 News. You two should know.
So I think we've answered the 30% is probably.
All right, so there's one, let me see if I can find it. There's the biggest, let's see if I can find it. Biggest elephant toothpaste. They did one outside of a house one time. Look at this one. This one's kind of cool. So that one's pretty big. And I know these videos are choppy, I'm sorry. So let me show you one more that you could actually do at the house, because you guys, you might have hydrogen peroxide at your house, but you probably do not have potassium or sodium
Probably
iodide.
pretty good. Look at, now the nice thing about
Okay, so let me show you what you could do at your house if you want to try. Okay, let's see. You could give this one a go. This is called, sometimes it's called instant ice, sometimes it's called quick ice. Here we go. Okay, I do want you to know, if you try that, let me tell you two different ways you could try this at your house if you wanted to. One, notice that, what do you think this bottle of water is? Hot, cold, room temperature? What do you think it is? What'd you say?
Cold.
Yeah, this is cold water, okay? So if you could probably put this piece of ice on a plate or something. You have a nice, pretty cold bottle of water, and if you pour it slowly over the ice, you may be able to get instant ice. Another thing you can do, really depends on your freezer, but you could take a bottle of water, put it in your freezer, maybe for an hour, okay? So it really depends on how cold your freezer is. Take it out, very carefully take it out. You look at it, it's not frozen. Slam it on your countertop or on your table, and it should freeze and turn into like a slushy. So that's kind of cool too. So you can try that if you want to try that at home. Let me know if it works if you try it. All right, so I wanted to show you guys those because we're going to talk about what causes that stuff to do that. That's part of what we're going to be talking about when we get into chemical reactions. But also, if you were thinking about what state of matter that stuff is, what state of matter would you say it is? Mandy, what state of matter would you guess the quick ice is, or the instant ice?
I don't know.
Don't know?
Maybe a salt or no.
Mm-mm.
I don't know. It's like both.
It's kind of tricky, right? So that's the thing. So what are we actually, that leads us right into our next thing. So I want to know what you guys know about matter. So I'm going to put a link into the chat, and I want everybody to go in and tell me at least one thing that you know about matter. Okay, so let's see. And I'll share the screen and I'll show you, it's really easy how it works. You just double click on the box. Okay, and you can type. So I'll share. Okay. All right. Very nice. So for instance, I can double click. See how I just double clicked and it opened this box. You don't have to type a title if you don't want to. Like I can just say, I know that matter, it's kind of what someone else just said, matter makes up everything. And then I just click off and it's there, okay? Matter takes up space, very nice. Solid, liquid, and gas, good. They're small, everything we can see or can touch, which is basically everything. I want to see how much we know, because that tells me how much time we need to spend on certain things. Like if we kind of know solids, liquids, and gases, then maybe we don't have to spend a lot of time on that. Ooh, very nice. Matter cannot be destroyed. There's another part to that. Let's see if somebody else comes with it. Very nice. Somebody else came up with it. Very nice. Cannot be created nor destroyed. See, I knew this was going to be a good unit. Very nice. Okay. Someone right here said they're small. Anybody know the stuff that makes up atoms? The things that make up matter. I already told the answer. Atoms. Atoms are the things that are very small. Very nice. And oh, I see somebody typing another word, which is true. So go ahead and type what you were typing. That's true. Very nice. Molecules. Okay, that's also part of matter. For sure. All right. Anybody know the two things that all matter has? All matter has this and that. Let's see if anybody knows that. Let's see. Ooh, you guys are good. Protons and neutrons. We're going to talk about that in the next unit too. Yep, that's included in matter. You guys are ahead of the game. Good. All right. Atoms and molecules. Very nice. So, and all this stuff is interconnected. So you have atoms, molecules, which are made up of electrons, protons, and neutrons. Okay. And these atoms and molecules are what make up matter. Okay. Which cannot be created or destroyed. Okay. And then matter takes up space because it makes up everything that we can see or touch. And those atoms and molecules and protons and electrons and neutrons, they're all very small. They're very, very, very small. Okay. So today, what we're going to focus on is the fact that we've got all of this stuff. So now we're going to figure out if we have to classify matter, okay, we have to classify it, we can classify it into these three categories, okay? And really, realistically, and this is why I asked Mandy that question, realistically, we're always taught that the phases of matter are solid, liquid, gas. And there's also another one. Anybody know what the other one is that sometimes people talk about? You can either unmute or just type it.
Plasma. Plasma,
very nice, okay? But realistically, in those categories, you really have subcategories. We just don't talk about them. In some classes we do, we won't talk about it in this class. But if you think about it, like the instant ice, it's like, is that a solid, liquid, or gas? Is the elephant toothpaste a solid, liquid, or gas? Silly putty, Jell-O, like, is it a liquid? Is it a gas? Is it a solid? Because if you think about, when you think about solids, what do you think about? How do you know something is a solid typically? Somebody unmute and tell me. Or I'll call someone. Let's see.
It probably hurts when you run into it.
That definitely probably hurts when you run into it or if you get hit with it, right? I went to a baseball game yesterday and this kid got hit with a baseball and I was like, that probably would not have hurt as much if it had been a liquid, okay? All right, so let's see. So what we're gonna do today is we're gonna watch part of a video. It's the first half of your homework. And then we're gonna watch, you guys are gonna watch the other part from homework. So we are doing this video here. Okay, so in this folder, in the matter folder, Making sure you can still see that, okay? In the matter folder, we're in states of matter, physical and chemical properties. We're gonna focus mostly on the physical and chemical properties on Thursday. So let me move this here, okay? So the video link is this right here, GPB 201, where it says click here. I'm gonna play it on my computer. It may be a little choppy. You do need your notebook. I'm working on the Google form for this. So for now, just open the PDF and just write it on paper. Some people will say they were able to type on top of the PDF, but I'm gonna make a Google form moving forward. So I'll get that done as soon as class finishes, okay? All right, so I'm gonna click this link. We're gonna watch part of this video. We're gonna try to get through that first page, and then the rest of the page is just your homework, okay? Any questions? I'll give you guys a second to find that first, okay? But then for homework, you'll just scroll down, there's a big play button, and that's where we're gonna be, okay? So I'm gonna maximize this. I'm gonna give you a few seconds to pull up the notes on Schoology and or to get your notebook so you can write down some stuff.
Wait, how do I find this video? Like once it's time for us to leave.
Say that one more time.
How do I find this video? Like to do the other part of the.
It is right here where it says watch the following video and complete the attached notes. And it says click here. This is the video. It's going to take you right to this page. And then you just scroll down and it's this video right here. So we're going to probably get through the first 10 minutes. And then you'll probably have like another 10 to 15 minutes to watch for homework. You don't have. Go ahead.
Sorry, is this the guided note sheet? Like, is that what we're taking notes on? Or are we just taking notes?
So like if you have a printer or something, you could print this out, or if you can download it and write on top of it. Let me see if I can write it. Oh, you might can. No, I can't type on top of it. I can select text, but I can't write on top of it. So if you want to just write it in your notebook, I'm going to, like when they put this up, I'm going to pause it. So there's never longer than like this. Physical properties can be blank without blank matter. So I'll pause it and you can write all that down if you want. Okay. So if you want to do all your notes on paper, that's completely fine. So we're doing this page in class. We'll probably get through phases of matter. We may not get to this. And then for homework, you'll do from here down. Okay. So this is what we're working on right now in class. All right. Anybody need a couple minutes before I start the video? Take that as a note. All right. So here we go. So usually when you really need to take notes, you'll hear a bell, okay? But it doesn't hurt to take a couple of side notes too, like when you don't hear a bell, okay? All right, here we go.
In the first unit of our chemistry studies, you learned all of the background you'll need for chemistry. Now, in our second unit, it's time to study matter. After all, we did say chemistry is the study of matter. So what is matter? Well, it's the stuff that makes up food and drinks. It's the stuff that makes up the clothes we wear. It's the stuff that makes up the air we breathe. It's the stuff that makes up, well, I think the list could go on forever. This study of matter seems like a daunting task. So let's break it up into smaller chunks. I'll give you some ways to classify different kinds of matter, and that should make it easier for you to study. But first, I think we need to understand physical and chemical properties and changes to help us with our classifying.
In this lesson, you will define physical properties, chemical properties, physical change, chemical change. Describe the phases of matter. Label properties as physical or chemical. label changes as physical or chemical, and state the law of conservation of mass.
First, let's see if we can define physical property.
Physical properties can be observed without chemically changing matter.
You better write that down. Physical properties can be observed without chemically changing matter.
Okay, so this is what you're writing down. All right, unless somebody says they need a few more minutes, I'm going to go ahead and hit play.
This means that we do not have to perform any kind of chemical experiment to observe physical properties. Let's look at a couple of examples.
The physical property known as malleability relates to how readily a material's shape can be changed. In general, most metals are malleable, while nonmetals are usually brittle. Malleability refers to the material's ability to be hammered, rolled, or pressed to thin sheets. Steel is used in the manufacturing of car bodies and thousands of other products because it is strong but malleable. Another physical property of matter is density. Density is a measure of the amount of matter contained in a given volume. Density is figured by dividing the mass of a given material by the volume and is usually expressed in grams per cubic centimeter. The density of water is 1, making the density of anything that floats in water less than 1, while anything that sinks has a density of more than 1.
Just to see if you get it, can you think of some physical properties of this balloon? What color is it? How would you describe its shape? Can you say anything about its density or its texture?
Okay, so all those questions he asked you will have to deal with physical properties. It's things that you can see or you can observe without having to do anything to the balloon, okay? So for instance, color, like he said, obviously that's probably the first thing you notice, the shape, and then the texture, and then the density, which remember he said anything that floats on top of water has a density of less than 1. Okay, so.
Stating that the balloon is red, that it is round, that it is less dense than water, and that it is smooth are all examples of physical properties. Now that you have the hang of that, let's define chemical property.
Chemical properties describe how a substance interacts with other substances.
You better write that down.
Okay, write this down. All right, unless somebody says they need more time, I'm going to assume we can continue.
Chemical properties describe how a substance interacts or reacts with other substances. This means that we will need to perform experiments to observe chemical properties. Let's look at a couple of examples.
One very important chemical property is reactivity. Many substances readily interact chemically with other substances. The majority of metals are highly reactive, tend to combine with other substances to form compounds. Corrosion is a common example of the reactivity of metals. Iron, copper, and most other metals tend to corrode when they come in contact with water and oxygen in the atmosphere. Because of this, metals are commonly painted or covered with less reactive metals such as zinc, which resist corrosion. Aluminum, along with zinc, is one of the few metals that does not easily corrode. It reacts with oxygen in the air to form a thin oxide film on its surface that protects it from further corrosion. That, along with its light weight, is why aluminum is used so often for canning beverages. Two other chemical properties are combustibility and flammability. A substance is combustible if it will burn. A flammable material will ignite easily and burn vigorously. Using these definitions, we would classify wood as combustible and gasoline as both combustible and flammable.
Look at these properties and see if you can classify them as physical or chemical. You need to put this in your notes so you can refer to it later. Make two columns on your paper, one labeled physical properties and one labeled chemical properties.
Okay, so if you make a column, one says physical, one says chemical, he's going to give you some, and then he's going to list some, and you got to decide where they go, and then you can check at the end to make sure you put them in the right spot. Okay, so make two columns, physical properties and chemical properties. Right.
Let's start by listing the examples in the video clip we just saw. Both malleability, which is the ability to be hammered into thin sheets, and density, which is the mass per unit of volume, are physical properties. Reactivity, combustibility, and flammability are all chemical properties. Reactivity describes how a substance will interact with other substances. Combustibility and flammability both relate to a substance's ability to burn. Now you try some. I will list a property and you write it in the appropriate column. Color.
Okay, so pick which column you think color goes in.
Texture.
Okay, so texture is like, is it soft? Is it hard? Is it furry, scratchy, smooth, rough? Which column you think that goes in?
Acidity.
Acidity, A-C-I-D-I-T-Y, acidity. Okay, so think about where you think that goes. Basically, if I put acid on something, what would happen? That's what we're trying to figure out. So would that be a physical or chemical property?
Solubility.
Solubility. So what that means is when I pour some salt or some sugar into a liquid and I stir it and it disappears, or it looks like it disappears, that's solubility. That's S-O-L-U-B-I-L-I-T-Y. S-O-L-U-B-I-L-I-T-Y. Figure out which column you want that one to go under. That one can be kind of tricky, but we'll talk about it. So dissolving, basically, that's what solubility is, when you dissolve something.
Ability to rust.
So rusting.
Mass.
The last one was rusting, rusting. So like when you go outside and you see a piece of metal that's been in, I don't know, it's old, it's been outside, it's rained on, it's rusted. And then this one is mass, M-A-S-S.
Good. Let's see how you did.
All right.
If you missed any, be sure to change it in your notes. You should have put both color and texture in the physical properties column because both of these can be observed without chemically changing the substance you are observing. Acidity describes whether or not a substance is an acid and would be listed in the chemical properties column. Solubility sometimes confuses students because it sounds so chemical. But solubility just describes how one substance dissolves in another without being chemically changed. So it would be listed in the physical properties column. Next, we have the ability to rust. If you think about your bicycle being left out in the rain, you can see that something has definitely happened to that substance. Chemically speaking, you have a new kind of matter. So ability to rust would be listed in the chemical properties column. Finally, we have mass. Think about when we were learning how to use the balance. We just put the item on the balance and found its mass. No chemical changes there, so mass would be listed in the physical properties column.
Any questions about those? Sorry. Okay, I'll leave it there. Just make sure you got them all. All right.
Before we move on to discuss physical and chemical changes, let's talk about one more property of matter, phase.
What do you notice that looks different about each of these? Well, let me ask this. Let's see. Anthony, what do you think these little red dots are? Or Paul? Anthony or Paul? What do you think they represent?
The red dots, are they like atoms?
Yes, exactly. So the whole reason, the whole way we tell the difference between a solid, liquid, and gas has to do with how your atoms are arranged. So it should make sense that this is a solid. What do you notice about a solid versus a gas? Melissa, what do you notice about a solid versus a gas?
The solid has more atoms than the gas.
Yes, and realistically, it's not necessarily, so it definitely looks like in this picture it's more, but it's just the fact that if we're looking at the same amount of space, it is more and they're just super tight together. Okay, so let's see if we can get through at least a couple definitions and then we'll be done for the day.
What do we mean by phase of matter?
Phase of matter refers to whether a substance is a solid, liquid, or gas.
Correct. Now, let's see what you guys know about solids, liquids, and gases.
The students are going to investigate solids by doing a simple experiment with a rock. They place the rock into a box to see what happens to the shape and volume of the rock.
The shape of the rock does not change no matter what container it's in. The volume of the rock is also the same out of the box and in the box, which we could check by water displacement if we wanted to.
Trying to earn some brownie points. Well, you're correct. We say that solids have a definite shape and a definite volume. Based on what you know about the particles making up a solid, why do you think this is the case?
Well, the particles in a solid are packed very close together.
Right, and those particles, just like Paul just said, are the atoms. Okay, so get that down. All right. Anybody still need time?
So I guess they don't have much room to move around. That would give solids definite shapes and volumes.
Now the students are going to investigate the shape and volume of a liquid.
The liquid in the graduated cylinder has a long and cylindrical shape and a volume of 50.5 milliliters. Now that the water is in this beaker, it is still cylindrical, but it is now a short and fat cylinder. The volume is right around 50 milliliters. So the shape of the liquid changes, but the volume stays the same.
We say that liquids have indefinite shapes with definite volumes. Do you think you can explain this in terms of the particle arrangement of a liquid?
A liquid has particles that are relatively close together, but with more room for moving around than the
Okay. And remember, indefinite just means it changes. Definite means it does not change. Okay. All right, we got one more as we close out. Tell you what, I'll just let you guys pick up the last one. So when you guys do your homework, you need to start around 9 minutes and 50 seconds. Okay, 9 minutes and 50 seconds is where you guys will need to start. Any questions? Let me ask you this. What do you think is going to say for gases?
They're both indefinite.
Yes, they're both going to be indefinite. And then the particles are going to have lots of room. It's a lot of space in between them. Very good. Okay. Any questions about what your homework is? Okay. The more you guys are on top of doing your homework, the more we can do the homework in class. So, and when I say homework, I mean like watching the videos. Okay. When I start giving out these homework quizzes again, it's going to be, if you don't turn it in, it's just going to be a 0. Okay. I think I was so stressed last time because I was trying to help you guys pass. And yeah, not that I don't want you to pass, but all right. If you don't have any questions, I will see you guys on Wednesday. Your homework is just to finish these. I did put the Google form up. So if you want to do it on the Google form, you can do it on there. Okay. See you guys Wednesday. Bye. See ya.
Bye.
See ya. Bye, Ariane.